Welcome, Hornets. In this video, we're going to be talking about the first derivative test. And you'll notice a graph that should be very familiar to us. This is simply a sine curve. Now, the reason why I'm looking at the sine curve is because it has a relative maximum and a relative minimum on it. And that's what I'd like to look at. Notice that in this sine curve, we have an increasing interval and we have a decreasing interval. Now we know that when we have an increasing interval, our derivative, in this case f prime of x, is going to be greater than 0. And on this side, when we have a decreasing interval, our f prime of x is less than 0. Well, notice that the maximum has to happen when we have a critical value. So our f prime of x is equal to 0 at c. And that's been identified right here. Notice f of x has a horizontal tangent lines at c and d. Therefore, these are both critical values where the derivative is equal to 0. Now, for the first derivative test to occur, we have to have a function that is differentiable, it's continuous, has a critical value, and has a change in sign for its derivative from a positive to a negative. Notice in this situation, we have decreasing f prime of x is less than 0. Critical value is right here. F prime of x is equal to 0 at d. Once again, identified by the horizontal tangent line that's provided to us. And then we have the increasing interval. And with this increasing interval, our derivative once again changes into a positive. So when we're talking about the first derivative test, we're talking about a change in sign for f prime. Now, it's important to remember that if there is no change in sign, things are not what they appear. Notice, always increasing, but going flat for a moment. So increasing, flat to increasing, shows no change in sign, and therefore we are looking at a situation where we do not have a relative extrema. Same thing can happen going in the other direction. Once again, decreasing, flat right here, and continues decreasing. Once again, a situation where we do not have a change in sign. So that's important. We have to have a function that's continuous. We have to have a function that's differentiable. We have to see a critical value. And we also have to see a change in sign. Now, be aware that if we are looking at a critical value of the f prime being undefined, that could happen at a point. And we could have an increasing followed by a decreasing with our undefined critical value at top as well. So there are lots of things that could happen. We have to be very careful as we're approaching them. Now, by definition, when we're talking about the first derivative test, and I'd just like to go to our textbook real quickly, just so that we get our wording down right. We are talking about that change in sign for our first derivative test. So here we go. Let's take a quick peek. This is from our textbook. Notice f prime changes from negative to positive at C, then f has a relative minimum. If f prime changes from positive to negative at C, then f has a relative maximum. Notice that C has to be a critical value of a function f that is continuous on the open interval C, and f is differentiable on the interval except possibly at C. Then we could have the following. Now, keep in mind that as we go through, we use the first derivative test as a means of sketching a curve. Sketching a curve. So we're going to see this again when we try to sketch a curve. Let's just write down our three basic statements. If f prime changes from positive to negative at a value C, where C is a critical value, then f has a relative maximum. If f prime changes from negative to positive at a value C, where C is a critical value, then f has a relative minimum. At C. If f prime has no change in sign, let me rewrite that because I just slaughtered that, but it has no change in sign, then there is neither a relative maximum nor minimum. At C. So keep in mind, that's what we're looking at for the first derivative test. Thank you very much, and we'll be seeing it in the next video on curve sketching, and hopefully it will help. Thank you very much. Be well and be safe. Take care. Thank you.